Hello everyone, welcome to this video. In this video we are going to discuss a very interesting and beautiful phenomenon in nature. We are going to discuss today about the charges, positive charges and negative charges, right? Every material in nature have charges, right? There are two types of charges, positive charges and negative charges. So first we will see what are charges. It is the property of matter. Every material will have some property by virtue of which they will apply electrical force on one another. Okay, so look at this. There are two types of charges, positive charges and negative charges. We all know that. So there is a very important rule, right? There is a very important rule by virtue of which they will act on one another. First rule is like charges always going to repel. Positive charge is a positive charge. Both are like charges. So like charges, these all like charges going to repel one another. Look at here, they are negative charges. Both of them are negative, so they are going to repel one another. So, and next rule is the opposite attract. Positive charge and negative charge will going to attract one another. Okay, so these two rules are very important, by virtue of which they will going to interact with one another. Okay, every charge particle will produce some field lines of force. Like Michael Faraday, who discovered these lines of force, he said that every material, every charged particle will produce some lines of force, by virtue of which they will going to attract or repel with one another. Okay, look at here, there is a positive charge, right? The lines of force from this positive charge going to come outside like this. Okay, and for negative charges, lines of force going to come inside. Okay, the direction will be inside, and for positive charges direction is outside. Okay, this arrow pointing outside for the positive charge, and this arrow is pointing inside to the negative charge. So you will see here a very important interesting phenomenon. What is happening? Look at here, the lines of force coming out from positive charges going to interact with negative charges and go inside of the charge. So therefore they are going to attract one another. Okay, look at here, this positive charges, if we going to put two positive and negative charges, they are opposite charges. So lines of force coming out from positive charges going to be go to the inside of negative charges, like pointing in this direction arrow. Okay, so they are going to interact and attract one another. Okay, these field lines are radially outward for positive charges and radially inward for negative charges. We have seen this, and there are some properties of charges. By these properties, charges going to interact with one another. The first property is charges are quantized. It will be multiple of an integer, integral multiple of E. E is the charge of electron. Yes, and second property is charges are additive. We can add them by addition. Okay, and third property are the conservation. Charge will be conserved. It will be always conserved. Charge will not be lost. If we add the charges, charge will remain same. Okay, and types of materials, we need to understand there are some different types of materials available in nature, right? Every material is not same, right? Metals are different from woods, right? metals are conductors. They can conduct electricity freely. They have free electrons. But insulators, meaning woods, don't have free electrons. So electricity don't flow fluently in insulators. They don't have free electrons. So there are three types of materials: conductors, insulators, and semiconductors. Semiconductors are materials we make them in laboratory by some doping. Okay, semiconductors like P type semiconductors and N type semiconductors, right? So these are the types of materials available in nature. Okay, so conductivity is a property by virtue of which electricity can flow in conductor. Okay, quality of that material, it's a quality of that conductor. So quality of a material by virtue which tells about how good a conductor is. It will tell you how good a conductor is, meaning how freely an electron can move in that conductor. Okay, and at the same time insulators have dielectric strength. Dielectric strength tell you how good an insulator is, the quality of my material which tells about how good an insulator is, right? The effect of temperature on dielectric up to which dielectric is constant. Okay, after some amount of temperature, dielectric strength would break down and it will behave like a conductor. There is a property of that. Okay, so we have learned many important things. So next thing is method of charging, how we can charge a material, and some methods by interaction of which we can charge them. Okay, so first is a rubbing. We can rub some objects. If we rub them, electricity is flow from one object to another and they become induce. Electricity will induce in those two materials. In one material positive charge will induce and another material negative charge will induce. Okay, and by conduction, electricity can also be provided to a material by conduction. If we conduct electricity by some metal wires like that type of material, okay, we can conduct electricity and provide electric charges to that material. And by induction is a property by virtue of which we can transfer electric charges to a material without touching it, right? Without touching it. How it is possible? Okay, very interesting. So if there is a material like this, if it have negative charge, it has negative charge. So if we place this material around another material which is neutral, means this have no electric charges. So this have negative charge. So what will happen? These negative charges will attract some positive charges in this material, right? Opposite attracts. So some positive charge will induce in this direction. Okay, and if there is positive charge in this direction, there is equal number of negative charge will also be induced in this material in other direction. Okay, in other side of that material, right? So let's see induction in next. Okay, in the next there is very good explanation of induction. Okay, the electrostatics deals with static electric charges. Static electric charges is the property of electrostatics. Okay, in this electricity at rest deals with charges at rest. Charge will be always at rest. They will not move in this study of our electrostatics. So study of interaction of electrical effects due to static charges. These electrical effects we have studied so far, and this interesting phenomena of nature comes under electrostatics. And important points about conductor. So conductor are the materials which conduct electricity very easily. Okay, they have free charges. Okay, but insulators don't have free charges available, so they conduct very hardly. Okay, they have dielectric strength. So some important points about a conductor. Conductor have charge inside on its conductors have charge inside reside on its outer surface. The in the outer surface of a conductor there will be charges available. Okay, there will be free charges. Okay, due to mutual repulsion and goes up to maximum distance. This is the property. Okay, this is a property by virtue of which the if we add some charges to a conductor, okay, they will repel one another. So what will happen if they repel one another? So they will go to maximum distance apart from each other, and they will arrange themselves in this way, right? They have arranged themselves and in the maximum distance available for them. Okay, in a conductor, charges will always flow at the surface of the conductor. They will not reside in the center. They will always come outside because of the mutual repulsion. Okay, they will repel one another, so they can't be the center, because at the center repulsion the repulsion will be maximum. Okay, so they need to be in equilibrium position, so they will be at the surface of that conductor. This is the reason. Okay, and second property is surface charge density, means charge per unit area or per unit volume. So there is surface charge, so charge per unit area of that conductor is inversely proportional to local radius of curvature. Meaning, if this is a material, is you can imagine or draw some circles here, right? You have drawn some circles, so these circles have some radius. In every place there will be a circle. You can understand here. In every place of this every place of the surface of the conductor, there you can imagine a circle. So every one of that circle will have some radius, right? Those radius is inversely proportional to what? The surface charge density of that conductor. This is the second phenomenon, second property of that conductor. Okay, and third property is electric field inside a conductor is zero. So in the center or the inside of a conductor, electricity will be always zero. Okay, this is the third property. And fourth property is conduction only takes place in metals. So we know that metals have free electrons, right? But insulators don't have, like wood don't have free electrons. So metals, conduction will take place only in metals. Okay, metals have free electrons. So next we have to understand about Coulombs law. So we have learned and understand that what are field lines. Every electric charge, like this is a positive charge, it will produce some field lines. So these field lines will produce some electric field around it. This charge will have field around it. Okay, what is it? What is electric field? Electric field, by virtue of which electric charges put some field lines, those field lines will interact with another charges and produce some force. Okay, this force is given by Coulombs law. Okay, the forces of attraction or repulsion will made by this charges is given by Coulombs law. So what Coulombs law says? Okay, first of all, Coulombs law gives the relation. Okay, that's F equal to K Q1 Q2 by R square. What is K? K is a constant. We will say it 1 by 4 pi epsilon naught. Okay, this is a constant. Its value is 9 into 10 to the power 9 Newton meter square per Coulomb square. So here is epsilon naught. Epsilon naught is the absolute permittivity of free space. Okay, Okay, every medium means air or every dielectric material will have the permittivity of that space. Okay, every dielectric will have the dielectric constant. Dielectric constant is epsilon by epsilon naught. We will learn in the next. Okay, this is the epsilon naught by epsilon naught. Okay, this is the dielectric constant. Okay, so epsilon naught is the absolute permittivity in free space, and epsilon is the permittivity in medium. Okay, in a medium like air will have the permittivity of that dielectric, so the ratio between them is the dielectric constant. Okay, and principle of superposition, this force, okay, which have created by those charges have follow some superposition principle, means we can add them together. Every force, you can imagine some charges in like this distribution of charges. This is a q1 charge, q2 charge and q3 charge, so they will produce some force one another. So we can add all of the forces they have produced on one another. So this q1 charge will produce some force on q2 charge, and like that it will also create some forces for him and him. So these all forces can be added like this. Okay, f1 plus f2 plus dot dot dot. There will be many charges available in this space. Okay, we can. So if 3 or more than one force on a point, then total force at this point will be factor sum of all these forces. If there are more than 3 or 2 forces in a single point or single space, we can add them together. So electric field, these charges will produce electric field lines. Okay, these electric field lines will produce electric field. So electric field at a point is defined as electric field strength of an strength of that electric field can be calculated from Coulombs law. Okay, this strength of electric field is E equal to F by Q naught. Okay, Q naught is a point charge in this distribution. Okay, so we can conclude a given charge distribution acts as a source of electric field. So what is the source of electric field? We have learned that source of electric field is the charges. Okay, and second is this electric field exerts a force on any charge that is present in this field. It will produce some force on another charge if it is in their field. Okay, if it goes outside of their field, they can't produce force on them, they can't influence them if they are outside of their field. Okay, only and only when they are present at their field they can interact with them. Okay, this is the rule. So positive charges feels force in the direction of electric field. This is the very important rule you need to understand here, that positive charge like this is a charge, positive charge. So the electric field lines or electric force, it will will be in the direction of electric field. Okay, the force will be in the direction of electric field. For positive charges, electric field will be in this direction, so it will feel a force in this direction. Okay, for negative charges it will be opposite, right? For negative charges, electric force will be in the opposite direction of their electric field. Okay, negative charge fields force in the opposite direction of electric field. Okay, there is electric field coming in this direction. Okay, so it will feel a force in this direction. Okay, so we have learned about very important properties and phenomena of electrostatics and about electric charges and how they produce electric fields and how they interact with one another, right? And these properties are very important in the understanding of electricity and magnetism. Okay, this is just the first video in this journey of this. It is very interesting, you can understand the concepts very easily and it is very interesting. So thank you for watching this video and looking forward to see you in the next video. So thank you.